So, how's it going? Good? Second day? Still going well? You guys still alive? That's good. So, the lecture slides of today are already available in the system, so you should have received the message telling you that you can access them there. I'll try to make them available to you before the lecture so that you can also just take notes along. First, I would just like to start by giving you some, yesterday I kind of gave you, I gave you like a very short overview of UCINet, which is one of the tools that you can use for network analysis, but there are many more. And this is a list, it's not comprehensive, but it's a longer list of different tools that you can use. If you don't like UCINet, you can use any of the others that exist out there. Some of them have some strengths and weaknesses. If you're working with huge data sets, then Yimga-Officiel is very good. So actually, if you want to use Twitter data, then you can use Yimga-Officiel, for example. And it has, you can work with API stuff, and you can just work very well with, has a way to communicate with Twitter. Stata, who has used Stata before? Yes, okay, one person, okay. So you guys are master students, you will most likely end up using Stata at some point. This is for doing regression analysis, and also Stata has some built-in tools for doing network analysis. The only thing is that it is very limited. So you can only do analysis of very small networks, which could be okay, but if you have higher demands, you might want to use something else. Okay, so today's lectures, yesterday you got an overview of what network analysis is, the story, where it comes from, what a network is, how to define it in terms of nodes and relations, the different types of relations that exist, etc. Today we're going to talk about how to collect data to do network analysis. We're going to talk about how to measure network data and how to characterize it. Because yesterday you saw a very nice picture popping up in UCINet, but you need more than that, right? So if you do an analysis, you cannot just put all sorts of pictures. You have also to tell a story about the graphs that you are producing. And that's what we're going to be doing today. And if time permits, then we're going to do a little bit more, or we'll just pick it up on a Friday. So, because I know you guys are having a long day, so I'll just start with something soft and perhaps interesting to you, so just need your attention. So, some consequences of networks. Actually, that is one of the very last topics in the course, but it's nice to already get you triggered about, okay, we're talking about networks, we're talking about how you can use them, but actually, at the end of this course, you're going to learn that it's not always, the story is not always very positive. So there can also be some negative consequences. For the guys being hired through social networks, it's cool, right? You get a job at the NBA, but for the team, it's not very good. And I decided to share this because there was somebody yesterday who gave an example of transfers in soccer, right? Who was it? Yes. So this is a similar example, but within the NBA. So. And actually, this article is a piece of actual research, and it was published in a scientific journal. And I don't know how many of you know, but us teachers, we also do research, and our purpose is to contribute to the scientific knowledge. And studying NBA players and how they're hired is also part of contributing to scientific knowledge. So if you want to read the paper, it's a really fun paper. Here's all the information. You can find it at the university and through Google Scholar, and then you can just read it for fun. Another nice and easy talk at the bar, right? You say, did you know that people who get hired through social ties, and if you end up at the NBA, you have 50% of winning versus 40, if you're not hired through social ties versus 45%. This is something nice to break the ice if you don't have anything else to talk about. So the agenda for today is we're going to talk about different network types. We already talked about some network types yesterday. In particular, we discussed one-mode and two-mode networks. Now I'm going to add another one. I'm going to talk about how to collect network data because ideally my hope is that you guys can take away so much with you, and most importantly, the ability to apply the information that you're obtaining during these 2 weeks and perhaps do, implement it in your master's thesis, or if you go work somewhere that you can bring in this knowledge and be able to carry out a proper social network analysis. So I'm going to show you how to collect the data, characterizing networks, the different measures for calculating importance in a network, and then we're going to talk about Granovetter's strength of weak ties, which is one of the main theory in network analysis. So network types. Like I said, we already discussed one mode and two mode. Who can tell me what is the main difference between one mode and two mode networks? Yes?
One mode is between people and two modes with organization.
Yes. So to make it more generic, one mode is you always have the same actors, and two mode you have different types of actors. Like if you say people can be is all people, one type of actors, and peoples and organizations would be two different types of actors, so that would be a two mode network. Today we're going to focus on one mode and another type that is called ego networks. I'm not going to be talking so much about two-mode networks because normally two-mode networks is something that you can collect data on, but we always convert the two-mode network into one-mode network. And when it is one-mode network, then we do all the analysis. So that's why I'm not going to be talking so much about two modes, only about one-mode network. And the one-mode network can be studied from different zooming perspectives. You can zoom out and look at the whole network. Okay, this is the whole network. Or you can say, well, I want to focus on a specific actor and its connections. And when you want to focus on a specific actor and its connections, then it's called an ego network, from ego, right? So you either look at everything as a system, or you look at a specific actor within the network, okay? And these are two different types of analysis, two different types of views. And just so that you know, that I don't want to get you guys confused, this ego network belongs to this whole network. Huh? So it's kind of like you either zoom out or you zoom in. And whether you want to do a whole network analysis or an ego network analysis depends on your purpose. What do you want to do? If you're interested in studying the social structure of a system of interactions, system is a key word, then you're going to look at the whole network. But if you are interested in studying a particular actor or how specific actors' characteristics and that of their relations explain whatever you want to explain, then you're going to look at ego networks. So it's a system view versus a particular actor view. And that is going to determine which perspective you're going to take. Okay? Now, there are also some practical reasons for having this whole network and ego network perspectives. Let's imagine that you want to do a study about the social interactions of people in Liège. If you want to do a whole network analysis, then you have to collect the data from everybody in the city. So it's going to take a lot of time, and it's going to cost a lot of money because you're going to have, I don't know, a lot of people collecting data, and then these networks are going to be huge, and there's too much information to handle. So if cost and time is an issue, then you can also consider, for example, ego networks. And with ego networks, then you can say, well, I'm interested in studying how certain university students interact socially. And then you can just sample different people, and then you study their ego networks. That is one approach. Both of them, I'm going to explain how each one of these work, and basically both of them have advantages and both of them have disadvantages. The main advantage with the whole networks is that you can really look at the whole system, right? But the problem is that because it is so costly and so time-consuming to observe a whole system, then sometimes samples are created. So instead of saying we're going to study the social interactions of all the people in Liège, we can say, oh, we're going to study the social interactions of all the people who live in the, what's the name of this street? The Rue Louvre, okay? So just pick all the people who live there, and we're going to study their social interactions, and that is my network. And with that information, I'm going to explain the social interactions of the whole city. It is one way to do it, but are you really capturing how the entire people of Liège behave? I'm not sure. Liège is a very big city with different people, different neighborhoods, so maybe it's not so good. And then if you consider that your whole network, and then you want to study how it looks, if you just look at the people who live in this street, that structure is going to be very different from the structure of the whole city. It's very likely. So when you're looking at whole networks and you decide to only look at a sample, then you might run into issues because, again, the whole network's goal is to look at a system, and by looking at a sample, you might not capture the entire dynamics of the system. And with ego networks, the problem is that you're sampling now, so you're taking specific people to infer about others, and it's the same story. So then you have to be very specific, and you have to say, well, I have sampled, 20 individuals, and these 20 individuals are representative of everybody here in Liège. Then you would have to make that argument. Okay. So how can you actually collect this data? So yeah, you can make figures, you can make all these stories about NBA players, but where do you get the data? That is the main question. That's $1 million question, or €1 million question. There are two ways. One of it is you can use primary data, or you can use secondary data. The primary data is the data that you collect yourself. So, for example, if you want to study networks in employees at Deloitte, you're going to have to go to Deloitte and you're going to have to collect that data. So that would be primary data. And the secondary data is the data that exists in public records. Can be, you can go to the municipality and then you can maybe, probably there are restrictions, but you can say, I want to have all the data on all the marriages and all the births and employment and whatever, and then with this information you can build networks of families, networks of employment, etc. So you can go and get this data from records. There are also specific databases that focus on collecting network data. And one of it is Bordex. Bordex is a data provider, and what they do is these people, they're crazy. They look at all the CVs of all the directors in all the companies, public and private, of the whole world. And by looking at their CVs, they can say, this director from ABN AMRO went to university in Amsterdam from 1997 to 2000, and this other guy who's the CEO of, some other company also went to Amsterdam in the same years. So then you can see all the history of all the directors, where they studied, the clubs they're part of, where they have worked, and then of course where all the other directors have worked, where all the other directors have studied. So then you can build networks of directors. And this is the data that I study, that I use a lot for my analysis. It's really rich. And you have the whole world, basically. There are also some, for that data, for Bordex, you have, your university has to buy it, and you have to have access to it. But then there are also other databases that you don't have to buy, and they're available. So, I think like the Enron emails, some of them are public, I think. Panama Papers, you can see them online. There's a lot of information. Twitter, etc., right, is out there. So you can access it, you can collect data from it, from these sources. So one strategy, if your research question is very specific, then you collect the data. If it's something that can be more general, that you can use public databases, then you can do that. So if you go the primary data route, meaning like you collect your own data, there are different ways in which you can actually do that. One of it is by doing questionnaires. Has anybody done questionnaires before? Surveys or yes? A couple of you, okay. So the same way you have done questionnaires in the past, you can do that for network data. And you can just simply ask people, depending on the type of network that you're interested, you can just simply ask them, hey, can you tell me the names and hopefully last names of all the people that whatever your research question is about. So you can ask them in an open question type of form where your subjects, they would just tell you, okay, these are all the people that give me advice, or these are all my friends, or these are the people that annoy me, or whatever your network study is about. So you can have this open-ended type of question. The problem is that when you have this open-ended questions of telling people, first of all, let's assume that you want to look at advice networks. And then you ask people, can you tell me whom do you ask for advice? Like yesterday, we talked with Crackard. Well, it is difficult because then the person has to think about everybody that he is asking for advice. So it becomes a difficult process for the interviewee, and it results in something called interview burden. I have a slide about it. And maybe they give you 10 names, and then 2 days later, the guy is like, hey, by the way, there was somebody else, and I forgot. So it's by just asking them, hey, tell me the names, then you can run into issues that the person forgets or whatsoever. So maybe it is a strategy when you expect the networks to be small. The alternative way is you can give a list like this with already identified names, and then you can just ask a person, can you tick the names of the people that you ask for advice? And the person just ticks. Okay? That is one possibility. Just a piece of advice, if you're collecting this type of data, make sure that your question is, how can I say, I guess politically correct would be the right term. So in the book, they discuss a case where they went to a company and they said, with whom are you likely to be friends? And everybody got very angry because they say, why should I give you information about my judgment, about friendship with everybody else in the company? Or if you ask them about list of people that you like, then it might be something sensitive, right? So then you have to just be careful with the type of questions that you're asking people to give you information on. So these are at least 4 different ways in which you can ask for, in which you can start collecting data on networks. So just asking people openly, can you tell me all the names, or giving some predefined lists, and you say, can you take out of these people? Of course, also by giving a predefined list, then you're putting a boundary also on your network. Just you have to know that every approach has advantages and disadvantages. Because you could alternatively, let's say you're doing this analysis in Deloitte, and then, I mean, you could have the names of everybody that works in Deloitte. And then you ask like this, but it's all the people that work there. And then you ask, can you check, put a tick mark if you ask for advice from those people? How many pages do you think this person is going to have to go through? A lot. Do you think this person is going to answer the questionnaire? No. So these are things that you have to keep in mind. Okay. So that is more like the open type of questions. This is another way of asking for collecting network data. So similar to the list that we saw before. Another way is just simply, let's assume that you want to collect data on who are your friends, with whom do you collaborate, like different types of network views that you want to get information on. Then you can just simply put the different questions like this, and then they just check, check, check across different names. So these are just some ideas in which you can actually, just for data collection. You can collect different types of information. So one of it is where the question is just simply yes or no. Are you friends? Do you ask for advice? Yes or no? But you can also get information on intensity or frequency. So how often do you talk to each other? Because maybe what you're interested in is just not simply are they friends or do they ask for advice, but it's how many times. How often are they communicating? How often are they interacting? And if that is the information that you're looking for, then there are two different ways. One is you can get absolute data or you can get relative data. If you don't want simply the yes or no type of questions. Yes or no are the simplest, just so that you know. And it's also going to work better when it comes to our network analysis later on when we do the measurements. Yes or no type of questions work better. But of course, that doesn't limit you. You can also collect data on intensity. The one thing that is important, as I already mentioned, is that of interviewee burden. And yeah, you don't want your study to fail simply because the way in which you're asking question is very, poses a burden to the interviewee, right? So first of all, you don't want to give 100 pages of lists, and then the person has to check who are the friends, et cetera, because you will not get any responses. Maybe you get one response, and then how can you build a network based on one response? So you need to make sure that you want to get as many responses as possible, because the more responses, the more information you have on your network, right? So make sure that your questions are short, they're concise, and that whichever approach you decide to go for, the open or the closed with the list, makes sense and works for your research design. The book from Borgatti, Everett, and Johnson discusses very much in detail all these approaches. So if this is something that you think you will do in the future, or that you're interested in learning about more, then you should really check out the book. Because they really give explanations, they give examples, and issues, so some issues that some scholars have encountered when collecting this type of data, etc. I already mentioned primary data so it's great. So I have to say one thing, when it comes to innovativeness, when it comes to publications, primary data is more useful because you have your very unique data and nobody else has. And therefore you can contribute more to research networks by having a unique data set that nobody else has, by looking at a unique company that nobody else has. So it's great, but it also has its limitations because, again, if you want to get information networks of a company, if that is what you want to do, it is very difficult that you get information from everybody. So you will just get a sample of that, so you have to be aware of what that is going to create for your research. If you think like, okay, collecting data like this is not my thing, then you can go for secondary data. Like I said, secondary data is the data that exists out there. And you can go to the Chamber of Commerce, for example. You can look at records of business partnerships. You can look at ledger sheets, for example, accounts of trade, any archival data. Even sometimes, and I was looking at an example where they retrieved network data from some letters that Galileo Galilei wrote. And in these letters, he was just writing like, oh yeah, today I talked to whatever, and I met the Pope, and then he was just explaining what he was doing. And from these letters, they just extracted all the names, and then they were able to make a network of Galileo. So all these public records can give you a lot of information. Anybody has seen the show, what is it called? The Roman emperors on Netflix? No? Yes? You've seen it? Cool. So, like I said, I told you yesterday, but I always think in terms of networks. I was watching this show. It's really cool. If you like Roman history or just like some, just to have some fun, I highly advise this show. And in every episode, they talk about an emperor of Rome. And then they tell you about the wife and all the alliances they were building and why they would get married to a certain family. And it was all networks, basically. So you can actually just watch this show and try to map these networks of Roman emperors and Roman empresses and the sisters and who killed whom, and it's really fascinating. So you can just build a network when you watch a show. There is there are a lot of secondary data sets out there that you may not even think of. So one is watching a TV show, watching a documentary, and then you can get information on networks. The other one use another source of public data. And the research question that was asked was, do conservative and liberal actors in Hollywood work together on films? So this is conservative liberals in the US, so are Republicans and Democrats acting together in the same movies in Hollywood. Are they? Well, there is a database called IMDb. Anybody has seen it or used it? Yes? No? Well, if you haven't, you can check it out. IMDb, the International Movie Database is called. And there you can see the history of every actor or actress. And you can see in which movie they have played, when, etc. And by looking at this information, you can make a network of who has acted with whom in Hollywood. And this is what these guys did. And this is also scientific research. Yes, it's fun. You just look at these actors in Hollywood, and then you can talk about it. So the idea was that, do we see acting as being something that breaks these barriers, political barriers? In this picture, the circles are Democrats, the squares are Republicans, conservatives. And even though you see some like mixing, in general, Democrats tend to work in movies with Democrats, and Republicans tend to work in movies with other Republicans. You could, of course, argue maybe it's about the topic, maybe there's some selection, maybe the director of the film is also a Democrat, him or herself, and then hires more person that think like him, etc. So you can go to IMDb and download this data and do a similar analysis. The IMDb, of course, doesn't give you information on political views. The political views were obtained from another data source. But you can look at, for example, gender. Are women working with other women as main actresses, or men, there are multiple men as main actors in a certain movie, or Academy Award winners work together with each other, etc. Twitter is another source of primary data. And this is just an example of an excerpt from Twitter where it's just 100 tweets where just search the handle Brexit. And then with Node.xl, which I mentioned in the start of the lecture, you can actually download all that data that meets that criteria. So this is, again, something that you can do. You can study tweets of, Trump or whatever. Actually, I have a colleague in Nijmegen in the Netherlands. He's looking at the tweets from Trump, and that's his data. So he's looking at these networks, etc. So that data is out there. It's free. You guys can get it. I told you can get data from watching TV shows. Are there any Game of Thrones fans? Just 2? Really? 1, 2. Oh, 1, 2. Oh no. This is the wrong audience. Okay. I guess you're just shy. I guess you just don't want to say. Or maybe after season 8, you change your mind. I don't know. But there are some guys. There are some guys. These are researchers in networks. And then they have their own page, the Network of Thrones. And what they did is they looked at every season of Game of Thrones, and then they looked at the scripts from the show. And the scripts are not available online, so they were able to get some scripts somehow. And based on the scripts, they were able to say, okay, if two people were talking to if two characters were talking to each other in one scene, then there was a tie. And they did it for every season of the show. And then they were not happy, and then they did it for every chapter, for every book that is out there. So you can see the networks for every book and the networks for every season of Game of Thrones. And this is the website. And guess what? They have their data available. So you can download the data, you can map the data, you can analyze the data. Just have fun with the Network of Thrones. Yeah. And because I didn't know how many of you were fans or if you have already watched season 8 or not, this is the network from season 1. I didn't want to give any spoilers. So you can see like Tyrion is like super connected, it has a lot of ties. You see Ned Stark being very important despite what happened in season 1, right? Catelyn Stark also having a lot of connections, etc. So you don't have to do something about firms or going to Deloitte and collecting data. You can also study TV shows, okay? I actually had some students that were doing a summer course with me, and they wrote a proposal to study influencers networks, and in particular makeup influencers, and then they were looking, I don't know if anybody follows makeup influencers, but they were going to study Huda Beauty and the makeup from some artist who's famous. She sings Rihanna. Rihanna versus the makeup from Huda Beauty and their connections with the Kardashians, and that's also possible. That's also possible, okay? And on a more serious note, you can find a lot of databases in your university's library. So this is, I just searched today, and this is where you can find databases. So I saw there's Orbis, and there's also Morningstar, etc. So you have a lot of information out there. You just have to work with the data and turn it into a network format in order to do your analyses. Secondary data also has limitations. And some limitations that I can tell you from experience is that a lot of these databases, they work based on names. So for example, if I want to look at a database of companies, there are people behind the scenes that fill out these databases. And they're doing it by hand. So sometimes they make mistakes. And the data, for example, some of the data that I work with, it's really a pain. For example, let's say I went to study the network of ABN AMRO, a Dutch bank. In this database, I have found more than 100 different names for ABN AMRO. I don't know why. So then you have to do a lot of data cleaning, so it's not perfect. If you're good managing data, then this is really a piece of cake for you. Sometimes the data can be nicer than others. This database, Bordex, that I told you about, is super nice, very clean, so that you don't have to do a lot of data management as with others. Okay, so let's assume that you collected your data, you are starting a networks project, and you collected your data. Well, that data and the way in which you have collected it, whether it is through questionnaires or through a survey, cannot be immediately used for network analysis. You need to shape it into one or two different formats, and this is the square form or the rectangular form. In the square form is a matrix of co-occurrences. I will show you what this actually means. And the rectangular list is something that is called an edge list. Remember yesterday I told you edge is just another way for tie or link. So this is a link list, if you will. So how do these data look? This is an example of a square form. So you have a matrix. And the matrix is a square because it has the same number of rows and the same number of columns. And the people, the order of these people is the same. It's the same order like this, and the same order horizontal. And a 0 means there is no connection, and a 1 means there is a connection. So that means that all the data that you collect, you have to make it like this. In Excel, text file, whatever. But it has to be shaped like that. So imagine if you are collecting primary data, and then you end up, you do the network of the whole Deloitte, thousands of people. Then your next task is to put it like this. Okay? The other way, which is a rectangular form, is easier, I think, for just from a data collection perspective. And the way it's you present it is just rows of data. So in this case, this guy, Bill Smith, he said he collaborates with Doug and Eric and Carrie. So you just say somebody has a relationship with somebody, and then another line, that person has a relation. You just put the pairs of people, and then you just go down the list. And actually, this data is exactly the same as this. Okay? The only difference is that here is represented as a square, and here is represented as pairs. And here, just to show you that what I'm telling you is correct, here you can see Bill connected with Eric, and here's Bill and Eric have a 1. Yeah? It doesn't matter which form you use. In the end, you're going to get the same network. Okay? So it's just a preference. It's really just a preference. Okay. So now let's assume you collected your data, you have it in the right format. Now what? What can you do? Well, the next step is to tell something about these networks. You want to be able to give some explanation about what is going on. And the idea is that you want to be able to explain something about the social structure, right? So you want to be able to say something about the data that you have collected. And the information that you should be telling when you have a network is you want to tell something about the size of the network. How many nodes are there? How many ties are there? What is the shape of the network? Are there any actors that are very important? And how do you define importance? And if you collect data at different points in time, then you want to be able to know if the network, if there's an evolution in the network. Is the network changing? Or is it always the same? This is also information. So if I talk from as an economist, then the information you want to tell is you want to give some summary statistics. You want to give some descriptive statistics about your network, right? When you have data, you give the average, minimum, maximum standard deviation. Similarly, when we have network data, you have to give some information that gives people a feel for the type of data that you have. Shape of the network. This is a network, you'll be seeing this picture quite often in the upcoming days. This is a picture of technological alliances and high-tech companies in the US. And this network is in 1990. And this network is in 1994. Is it the same? What is different? What is changing? Yes? The shape, okay. And what is it about the shape? Yes. And actually, yeah, and that's what I mean by shape, exactly. So the distribution of the nodes is different. So number one, there are more nodes than before. That is clear. Second, there are more ties also. If there were more nodes but no more ties, then we would be seeing a lot of disconnected nodes. Also, what you see is there are some blobs, 2 blobs in this year. You see this group here, and then there's this other group here, and then there's kind of these guys out there together, but there are just a few of them. There's some pattern that is being developed. In the beginning, they were kind of more spread out, and now you see some concentration, some clusters developing in the network. And these are some of the things that you want to be able to tell when you collect data throughout different years, network data throughout different years. Now, some things from yesterday that will be coming back today is that when you are describing your networks, when you are characterizing your networks, you have to be very clear about whether your network is directed or undirected. What was the key word, what was the key thing that you want to look for to see if it's directed? The arrow, yes. So this one is undirected, yes. And yeah, so you want to give your summary statistics, and then you want to give some key attributes, some characteristics about your actors. And there are other things that you also want to say. You want to say something about the network. Is it cohesive? Is there a core periphery structure? And are there communities developed? This is basically everything that I already said within the network, but now I'm going to formalize this. So the first concept is called cohesion. And anybody speaking Spanish here? No? A little bit. Okay. Who speaks French here? Okay, good. So that's why, so the word cohesion comes from connectedness, from knittedness. And I have the Spanish meaning, enredado. But then I thought, yeah, I'm not sure how many of you speak Spanish. So then I also searched for the word in French. Emele? Yeah, it's good? Okay. Is it correct? Is it that word, or did I pick the wrong word? No? Yeah? Is it wrong or is it correct? Like it's really tangled, yeah? Okay. You know, sometimes Google Translate gives you the wrong word, so you have to be careful. And this word cohesion tells you how tight all the nodes in the network are, how socially cohesive the network is. And then there's a way to measure cohesion. And this way of measuring it is the number of ties divided by the maximum number of possible ties that can be formed in the network. So how does this work? So first we have to look at the maximum number of ties. And then the maximum number of ties that can be formed in a network is the number of nodes multiplied by the number of nodes minus 1 divided by 2, right? So if I have a triad there, the maximum number of ties that you can have is 3. It's 3 nodes multiplied times 2 divided by 2. The math is correct, right? Yeah, 3. And so for this closed triad, the cohesion measure is 1. And that is a maximum cohesion that you can have. It means if you have cohesion of 1, it means everybody is connected to everybody. A cohesion of 0 means what? No ties. There's 0 ties, right? So the numerator is 0, yeah. And this is a way to tell a story about how connected. So you can say 100% of the nodes are connected to each other. This is what it means, the interpretation of this number of cohesion. If you would have had 0, then 0% of the nodes are connected to each other. And of course, cohesion is bounded between 0 and 1. The meaning that you're going to give to cohesion depends on the context that you are interested in. In some instances, the more cohesive the network is, the better it is. In other instances, the more cohesive it is, the worse the news are for you. So, who can think of a case when cohesion, high cohesion is good? When would you like to have high cohesion in a network? Yes? In our family. Yes. Okay, so if you look at a family network, you may want to have high cohesion. Then everybody's talking to everybody, everybody's supporting everybody. Then it means it's a happy family, right? When would you not like to have high cohesion? In the workplace. Why? Yes. So you can have in the workplace high cohesion may be good, may not be good. Actually, there's research showing that if in the workplace everybody is connected to everybody, then productivity goes down. So if everybody, let's say you look at a network, friendship network in the workplace, if everybody is friends, then productivity goes down. So maybe in that case, cohesion is not such good news because it will affect the performance of the firm. Now, I would like to trigger you guys to think about why would we want to look at cohesion, this measure, to talk about how the network is knitted instead of looking at just number of ties? Why looking at cohesion and just not simply? You can also say more ties, the more connected the firm is, the network is. Why? Why pick cohesion and not just number of ties? Yes? Perfect. You have to think in relatively, in terms of the relative size of the network. Okay? Because here we have a triad. Everybody is connected to everybody, but we only have 3 ties. That network also has 3 ties. So if you only look at the number of ties, they're equally knitted. But you can clearly see that one is cohesive, sticks together, and the other one is not. It has a lot of disconnected nodes. So it's good to think in terms of relative, with the relative thinking. The other concept that is important when you are describing a network is something called core and periphery. Core periphery structure tells you about whether there are some players, some actors that are more belonging to a core, belonging to a large piece of the network. And then there are others that are just hanging, that are more disconnected from the rest of the network. In this picture, you can actually see that in the center, there are a lot of nodes that are very connected to each other. And in the outside, there are a lot of nodes with very few connections. When you have this pattern, then you can say that there is a core periphery structure to the network. This is no core periphery structure. Everybody belongs to the same piece of the network. Here in this network, for example, you can see that there's actually not one core, but there are kind of like 2 cores. There are 2 clusters, and then you have these guys being more peripheral. And actually, this is not very strange. When you look at whole networks, and there's typically this structure of you having a core, and then you have some other guys that are just hanging around that are more disconnected. Do you remember this picture from yesterday? It's from the Union picture from the Silicon Systems company. Well, this guy, Hall, and Evo, and we kind of talked about this already yesterday. They were the ones that were very vocal, right? They were pro-union, and then they were vocal. But actually, they had a peripheral position in the network. And if we want to talk about influential actors in a network, the ones in the periphery are not the ones. that you should be paying attention to. Because they're in the periphery, they are more disconnected to the rest, so then they won't be able to exert that much influence. If you're interested in looking at influence, you may want to look at those in the core, the ones that are connected to everybody else. Another concept for characterizing whole networks is that of community. And community is the idea of having different groups within a network developing. And these groups are very tightly connected to each other among themselves, but disconnected from the rest. And here, to give you an illustration, this is from data collected from one of the largest telephone companies in Belgium. So it's local data. And then every link is phone calls, if they call each other. And the colors of the nodes, green is that the people are of speak Flemish, and red if they speak French. What do you see? Yes. There are some, but you see very concentrated, right? And actually, the bigger the node is the frequency of calling. So most of the calling happens within their own language. So there are Flemish-speaking people call Flemish-speaking people, French-speaking people calls French-speaking people. Some do cross-calling, but they're a different group. Okay. So you can look at core peripheries, you can look at communities, you can look at cohesion. Yeah. So the definition of community is just is a group of nodes that are more likely to connect to each other. And it is useful if your goal, for example, you want to look at how different groups are emerging within your data, then this is useful, looking at communities. Also, it's interesting to look at communities if you are interested in seeing how certain behavior diffuses. So if you want to send a message to French-speaking people, then you target somebody there, right? Because they're all very tightly connected to each other, so then this is going to spread to all French-speaking people. But not so much to the Dutch, Flemish-speaking people. Okay. Any questions about whole networks? Core periphery, communities, and cohesion? No? And all of these concepts can be measured, and UCINet can do that for you if you have the data. So you can go to analysis, and then you can compute all of these things. Before I talk about ego networks, then I'll give you guys a 15-minute break.